Now we're working on 2.2. This question deals with closure. Closure means if you take something and combine it with something similar, do you end up with something that is similar to the other two? Which doesn't make a lot of sense, but it's kind of like saying if you breed a dog with a dog, do you get a dog? Yes. If you breed a horse and a donkey, what do you get? A mule. So that is not closed. You don't get the same thing, the same result out of what you've just done. Okay. So this first one asks, if an integer is added to an integer, do you get an integer? What is an integer? A whole number including negatives. So if you take a positive or negative whole number and you add it to a positive or a negative whole number, do you always get a positive or negative whole number? Yes. So we say that the integers are closed under addition. If you take a whole number and you subtract a whole number, do you get a whole number? Always? No. Give me an example where that doesn't happen. 4 minus 7. 4 is a whole number, 7 is a whole number, but 4 minus 7 is negative 3. Is negative 3 a whole number? No. It's an integer. So whole numbers are not closed under addition or subtraction. If you take an integer and you multiply it by an integer, are you guaranteed to get an integer? Yes. Okay. If you take an integer and divide it by an integer, do you get an integer? Not always. Give me an example where that doesn't happen. 4 divided by 3. 4 is an integer, 3 is an integer, but 4 over 3 is not an integer. So for that one, we would have to say sometimes true. Okay. If you take a polynomial and you subtract a polynomial, do you get a polynomial? So if I take is the answer still a polynomial? Yes, it is. And if a polynomial is added to a polynomial, is that still a polynomial? Yes. What about a polynomial divided by a polynomial? No. Polynomials are not allowed to have variables in the bottom. So the division rule does not work. Okay. Let's do. Okay, we'll start with this one. How do we multiply this? We use distribution. So 9 times 8 is 72b to the 7th. And then 9 times negative 10 is negative 90b to the 5th. Okay, you guys know how to do that, right? What if I had 3x squared minus 6 times 2x squared? Let's not do squared. Let's just do. How do you multiply those? Do you guys remember? No? We put them in the box. 3x. Oh, sorry, wrong place. 3x minus 6 and 2x plus 3. 2x times 3x is 6x. 2x times 6x squared. 2x times negative 6 is negative 12x. 3x times 3 is 9x. And 3 times negative 6 is negative 18. Okay, and then we look for like terms. These go together. So we get 6x squared minus 3x minus 18. Okay. If this was a squared, then this would be a third power, and this would be a squared. Do I have any like terms? No, so we just string them all out. 6x to the third plus 9x squared minus 12x minus 18. Okay. What if I had something larger? How would you multiply these? Oh, good. You could do this. This times this, and this times this. This times this, and this times this, and this times this, and that. That'll work. Especially for longer ones like this, it's really easy to make a mistake. So I recommend using the box. And this could either be a 2x3 box or a 3x2 box. It doesn't matter. So x minus 4, 3x squared plus 6x plus 4. So this would be 3x to the third, 6x squared, and 4x. And then negative 12x squared minus 24x minus 16. And then you'll notice those go together. 3x squared minus 6x, x to the third, sorry. Minus 6x squared minus 20x minus 16. So hopefully that's all review. Is that everything? Yep. All right. That's it for 2.2. Get to work.